Now we're going to look at Chapter 23's example problem for fat content in pizza. This is still comparing the difference of two means. In this problem, we're going to be given the data to work with instead of just the summary statistics. So we have saturated fat content in grams for several pizzas sold by two national pizza chains. One we'll call chain D and the other one chain PJ. You can decide for yourself what pizza stores need to be represented by these, but this is what we're going to use. So we need to enter this into our calculator. It looks like there's 20 measurements for pizza chain D and 15 measurements for chain PJ. The question is, we want to know if the two pizza chains have significantly different mean saturated fat content in their pizza. Let's go ahead and look at the hypotheses. We're going to hypothesize that there's no difference in mean saturated fat count between brand D and brand PJ. If you look at the data, obviously, well, it's pretty obvious that the fat content in the first store, D, is a little higher than the PJ chain, although not for every single pizza, but overall, just eyeballing it, it looks like it might be that way. So in my hypothesis, I'm going to start with D and subtract PJ for my work. I'd rather work with positive numbers than negative numbers. So our null hypothesis is that the difference in the mean for D and the mean for PJ is 0. The alternate hypothesis is that there is a difference, and I'm not going to presume to know which way that it goes. I'll just say that it doesn't equal 0. If you look at the data, like we have an idea of which way it would go, but imagine if we weren't looking at the data to begin with. If we just wanted to compare store D with store PJ, we may not know at all which direction it goes. So make sure you put yourself in that mindset and don't use the data to influence you too heavily on what direction to go. All right, the model. Let's look at assumptions. We need independent groups. In this case, the two samples of saturated fat contents were chosen independently of one another. They're assumed to be independent. Certainly, they've got to be. They're from two different pizza chains. The randomization condition wasn't really mentioned in the problem. We're going to assume that the pizzas were representative of all pizzas by these two chains. Maybe they were selected random over a time period. We just have to make that assumption. Certainly, we don't just want to stop here and not do the problem because we don't know for sure if it's a random sample of pizzas. We're just going to move on and make that assumption. Now, one thing we need to do is to check the nearly normal condition. And remember, there's two ways. We need to look at the histogram and decide that the two groups separately are approximately unimodal and symmetric, or that the normal probability plot looks straight. So in order to actually make these graphs, we're going to have to input the data. And I'm not going to spend time, actually making these graphs. You should be able to make these histograms on your own. You should know how to do that by now. But just know that our next step is to look at that. So I'm going to go back and get the data. I'm going to go ahead and put it in my calculator. And I would like for you to pause the video and to verify that those histograms look valid. I already have my data in my calculator. You go to Stat Edit, List 1, List 2. So my List 1 is my D company. My List 2 is PJ. We can see that there are 20 data values for the first group and 15 for the second group. The number of pizzas here in each sample don't need to be alike. That's one thing that's kind of nice about this. I'll refresh your memory on how to make a histogram, but then you'll need to do them yourself for these two separate samples. Go to Second Stat Plot, I just selected the first one. I'm going to turn it on, and the type, select the histogram as the type. You can only do one at a time, so I'll do list 1 first. Frequency needs to be 1. I'm going to, whoops, didn't mean to delete that. Use second list 1 there. I'm going to bounce off of that entry because that's in alpha mode. And to graph this, I'm just going to use zoom 9, which will let the calculator, that's zoom stat, let the calculator decide what the histogram needs to look like. We can compare that to the histogram in our notes and actually see that our calculator histogram actually looks, for group D, looks kind of similar, definitely unimodal and symmetric, but a little bit different than this. Remember, your calculator is going to pick, the buckets that it thinks, are meaningful. You can manipulate with the window key. You can manipulate the size. You can actually replicate this exact same graph, but the purpose is to just see that it's approximately unimodal and symmetric, and for me, that will suffice. And you can do the same thing for the second one. Remember, your graph may not look exactly like this one, but close enough. Now, this is unimodal. Don't worry that it's 2 bars. It's still unimodal. It has one area in the graph where you have, the highest collection of values. Not super symmetric, but not a deal breaker either. So we can move forward with that. The other type of graph that we have is the normal probability plot. And what you would do on a normal probability plot is you would take a look at the graph to see that you have an approximately straight line. These normal probability plots were made with some computer software, and they additionally show these bands around each plot, and as long as the points are all within those bands, it's close enough to be considered an approximately straight line, and you're good to go. Real quick on the calculator, if you remember how to do that. Second stat plot, the normal probability plot is that last plot. Hit enter, and you can basically leave all these settings just like they are. Put in your data list. I'm going to hit zoom 9 again, and you can kind of eyeball that and be pretty confident that you're good to go on this nearly normal condition. Alright, so our conditions have been met. We're going to perform a 2-sample t-test for the difference in means of saturated fat content, it should say that here, between brands D and PJ Pizza. We'll use 32.757 degrees of freedom given to us by technology. This is the cart before the horse thing. We need to run the t-test on our calculator in order to get this degrees of freedom easily. Just as a quick check, you can add up the 2 sample sizes and it's going to be somewhere near that. Our 2 sample sizes were 20 and 15. That adds to 35, so we're close to 35. Anyway, we'll look at the output of the test in just a second on the calculator. Here's our summary statistics. And actually we can get all of this from our TI-84. Notice on this one I'm not showing any formulas or any work. On an AP problem or a test problem, you're going to need to show the formulas, show your substituted values, and then your final answers. For my math lab and for this problem, we're just going to go straight to the answers. So let's get this. Let's go back to our TI calculator and show this work. So I'm going to go to Stat Tests. I'm running a 2-sample t-test, number 4. Now this will be different from the last one we did. The last one we had stats in our pulse rate problem. Now we have data. So we're going to highlight data. List 1 and list 2 will be used. Frequencies are both 1 for what we're doing. We're doing a 2-sided test. Again, we're not going to pool. And let's calculate this. This is wonderful. And here's all of our values. We have a t-score of 4.8. Our p-value, or that'll indicate how unusual this is, 3.15 times 10 to the negative fifth power. So this is very small. Degrees of freedom, there it is, 32.757, which we could also just call 33. It also provides your mean for the x's, your mean, for list 1, your mean for list 2, standard deviation for list 1, standard deviation for list 2, and your sample sizes. So everything you need to know, I'm going to scroll back up there, and all of these values should match what we have on the PowerPoint or be very close. Let's take a look at that. So really the only thing on this page that the TI calculator doesn't provide is this. We would need this to make a confidence interval. We may need this to, in one of our concluding statements when we want to talk about what is the difference that we saw in our samples between the fat content of D and PJ pizzas. So you can do this on your calculator. Remember, you don't want to round in the middle of a problem. So the calculator has these all these values stored right now. So we can actually calculate that using variables. So I'm going to go to variables, then statistics, number 5. And before, when we use this, we may have used these values, which get populated when you do like 1 variable stats or 2 variable stats. This time we need to use variables that came out of a test. So if we scroll down on the test option, you'll see that it shows x1 bar, x2 bar, and this is what we want to use here. So I'm going to select A for x1 bar, and I'm going to subtract from the variables again, 5, test, and I think this is B, what I need. x2 bar, hit enter, here's my 4.716 repeating. So, jump back over to this, that's where that came from. Alright, let's move on. So some of the mechanics here, say you were doing this on a test or an AP problem, here is, the detail of all the formula work. For our t-score, the t-score we did get on our calculator output, but sometimes you got to do it all by hand, and you can use your calculator to verify it. But here we go. So this is the value. Our t-score is 4.823, and you can of course confirm this with the calculator output. I reran it so it would be on my screen, but there is 4.823. There's my p-value. Don't forget the times 10 to the negative fifth power. So this is all of our data. And now to just conclude it. Since the p-value is very low, we reject the null hypothesis. There is strong evidence to suggest that the 2 pizza brands have different mean saturated fat content. We have to say more than that. Let's go on. Brand D appears to have more saturated fat on average than brand PJ. The p-value is so very low that the difference is statistically significant and very unlikely to have occurred by chance alone. A follow-up confidence interval. I'm assuming this is a 95% confidence interval. It should say. We got the difference in the 2 means. And this is our margin of error. We have 32.757 degrees of freedom, which we can use in our calculator. It'll accept that, even though 33 is okay as well. And here's the confidence interval that you can manually do. We can also get that on our calculator. Remember to use inverse t in order to find this t critical value. On the calculator, we'll do stat test, and we want a 2 sample t interval. And we already have our data in there, so it's going to use this. I'm going to use a 95% confidence level, calculate that, and we should get the same values that, the same interval that we did that is showing on our PowerPoint. And finally, here's the well-written conclusion statement.